you are expected to know this formula. And so that is something you're going to be expected to know. An arithmetic sequence has a common difference. We learned that Tuesday. Has a common difference. The rule for arithmetic sequence is a to the subscript n equals a to the 1 plus n minus 1 times the difference. Now, sometimes you'll see it that D's in the front. Okay, so a to the subscript n equals, so n is the term you're trying to find. So it's the first term, second term, third term, fourth term, the number of term you're trying to find. A to the 1, well, if n is the number of term, if you have a 1 there, what do we know? What term is that? The first term. D is the common difference. All right. A geometric sequence has a common ratio because we learned the other day when it was a geometric sequence, it was multiplying. Okay, so you would have a common ratio. The rule for that is a to the n, so it both starts with a to the n, and then a to the 1, but instead of adding, we are going to, what did I just tell you were doing? Multiply. And then r to the n minus 1. So instead of having and this whole thing is being raised with that r. So instead of having a d, we have an r here. N is still the term you're trying to find. A to the 1 is still the first term. And r is the common ratio. N minus 1, yes. Okay, so you must know these two formulas. All right. So tell whether the sequence is arithmetic. If it is, state the common difference and write the next term. So I want you to do A, B, C, and D. Tell me whether it is arithmetic. If it is, tell me the common difference, and then give me the next term. Okay, so to find the common difference, you take the number, like this is 2 to 8. 8 divided by 2 is 4. 4 divided by 1 is 4, but 9 divided by 4 is not. Does that make sense? So each time you divide the one that comes after. So 9 divided by 27 is 1/3. Does that make sense? And then negative 45 divided by 15 is negative 3. So this is alternating signs. Any questions on that? Okay, so now we're going to graph. Okay? When you have the sequence, these are your y values. So this is like 1, 2, 3, 4. This is like number 1, number 2, number 3, number 4. So when when x is 1, the output's going to be negative 5. So at 1, 1, 2, 3, 4, 5, negative 5. And then at 2, negative 2. And then at 3, positive 1. And then at 4, 1, 2, 3, 4, you can see it's growing quickly here. And you don't connect those dots. Okay? Because these aren't a type of function yet. But we could connect the dots eventually, but right now we're not. What kind of function would this be if I connected the dots? Would it be linear, quadratic, or exponential? Linear. It's making a straight line. Okay? Here we have 1, 2, 3, 4. So at 1 is at 1. 2 is at 2. 3 is at 4. And 4 is at 8. Now if we connected these dots, I'm going to because I want to show you, what type of graph would this be? Linear, quadratic, exponential. Exponential. So this would be a geometric. This is arithmetic. And you notice with arithmetic, what type of graph is it? It is linear. Does that make sense? Okay, so let's come on down here and let's look at the rules, how we write the rule. Okay? So first of all, we're telling you this is an arithmetic sequence. Okay? You don't have to decide on these here. Okay, so in this first one, we're going to find out how do I get from 11 to 6, 6 to negative 1, 1 to 4, 4 to 9. What is my difference? What am I adding? 5. Does everybody see my difference is 5 there? Yes? Okay. What is my a sub 1? What is my first term? Negative 11 in the sequence. Okay, does everybody understand how I got those two numbers? All right, so I have the formula, and I recommend writing it every time because that will help you learn it. A to the 1 plus n minus 1 times d. And I'm going to plug in what I know. Okay, what do I know? A to the 1 is negative 11, and my d is 5. Okay, does everybody understand that so far? Okay, so then I'm going to simplify this. What would I do first to simplify this? This is the same thing we did in the beginning of all of Algebra 1. What did I do? I do parentheses first. I'm going to distribute. And so I get a to the n equals negative 11 plus 5n, bless you, minus 5. Does that make sense? Is that simplified completely? No. What can I do now? Add the 2, so I get 5n minus 16. Okay, is this a linear, exponential, or quadratic function? This is not a hard question. Linear, because the degree is 1. Okay? Now, if I were to ask you, okay, so that's what this problem's asking, but if I were to ask you, what is a to the 12th? Okay, so if I want to know the 12th term, what would I do? Plug in 12 for n. So I would say a to the 12th equals 5 times 12 minus 16. 5 times 12 is 60 minus 16 is 44. So this is the reason we need the formula, because just going down through here, it would be easy to find the next number, the next number, the next number. But what if I needed the 500th number? Do you want to have to keep adding 5 each time to get? Now, why is this useful? Well, a lot of times in like medicine and different stuff like that, they need to kill that bacteria at a specific, after it's grown so much, right? That medicine's going to target it at that spot. So that's what it needs to do at that particular number. So that's useful there. Yes, sir? No. That's what I just said. You have to know that. That's okay. With the geometric, we're not adding a difference. We are multiplying a ratio. So what? 2 times what gives me 12? So 6. So my R is 6. So instead of a D, we have an R here. And then my first term, a to the 1, is what? 2. And everybody understand where I got those from. And then, so I'm going to write my formula so I can remember my formula. So it's a to the 1. Notice both of them starts with a to the 1. And then now, instead of adding, I'm multiplying my R. And then n minus 1 is also the same. Does that make sense? This is an exponential like we saw in the graph above. So that will allow me to know that it goes there. Okay, so I'm going to plug in what I know. My a to the 1 is 2, my r is 6, and my n minus 1. So that's how you write the function. Okay, so you're writing the geometric sequence, you're writing the rule. Yes. Yes, you can do that too. Okay. All right, so again, it's not asking for this on here, but if I asked you again, this time let's ask for the 7th term. Okay, so if I wanted to know the 7th term, I would replace the n with 7, and then I would have 2, 6 to the 7 minus 1. So put that in your calculator, and somebody tell me what that number would be. No, it's just 6. What's 7 minus 1? That's an exponent. What's 7 minus? Is that what you meant as exponent? Okay. 93,312. Yes? Okay, so that's the 7th term. So let's talk a minute. There's how many terms here? 1, 2, 3, 4, right? What would the 5th term be? What would I multiply this by to get the 5th term? 6, and what would that be? Everybody do it in your calculator. 432 times 6. 432 times 6 is what do you say? Okay, so that would be the 5th term, right? Now multiply it again by 6, and you get 15,552. That would be the 6th term. Now multiply it again by 6, and then you would get 93,312. That's the 7th. So do you see why the formula is a whole lot quicker? Because what if I needed the 25th term? Do you want to sit there and have to multiply by 6 till you get to the 25th term? No, because all I'd have to do is put 25 in place of n. Okay, so you'll notice here the rate was 3. The first term was -5. Is this a growth or a decay? Growth. I know this for 2 reasons. Number one, the numbers are going bigger, and then the second thing is that it's greater than, the rate's greater than 1, right? So on this one, as I go, the numbers are getting smaller, so I know this is going to be a decay, so my number should be less than 1. Now remember, just because you see a fraction doesn't always mean decay. What if I had 3 over 2? Is 3 over 2 less than 1? No, so you always have to find that out. So the other thing is here, some people would argue, but Miss Lewis, -15 is less than -5. Do we look at the sign? No. What does the sign tell me? The direction. Y'all are learning so much. All right. So on the back of this worksheet, and this is not going to be a grade. I just know some of you are going to need extra practice in what I'm going to give you on the Go formative. So I want to show you. So on this first one here, what is the first term? -8. And is this a arithmetic or geometric? Arithmetic. And my D is? No. Looks like 4, but that's -8 to 12. So how to go from 12 to 32? 20, right? 20. Okay? So I could plug all this in, and when I do, it should go right to that one. So it'd go through that S and 3. I don't know why I jumped over to 3. So that would go here. These. So if you fill out, that's number 3 is an S, so down here you'd put an S. What's the matter? -28. I know, but look, we got to fill it in. Remember, we're not done yet. I did it in my head. -8, and then that's plus n minus 1 times d, which is 20. Right? So that'd be 20n minus 28. -8 is -28. Does that make sense? I just knew that it would be 20n, so I did that part in my head. Okay, so this is just practice that you can